Good afternoon, everyone. I'm Nikos Murtos, Professor and Chair of Aerospace Engineering, and I'm going to be your host today and give you a quick tour of our department and our programs. I can see there are still people coming in, so I'll wait another minute or so, and then I will get started. Okay, I will. I have a little PowerPoint that I want to share with you, and it's going to be a quick presentation, and then I want to hear what questions you might have about our department and our program, and what you want to know about it. So here it is. Aerospace engineering. I got to turn the music off. I had no idea I had music on. This was meant to be for the web. Let's see. Slideshow, presenter, hide, setup, show, slides manually. Oh boy, animations. I have no idea how to turn the music off. So I guess I'm gonna show the slides, from this view. Okay, can you guys all see the slide? Is that big enough for you? Feel free to talk. There you go. Okay, awesome. Yes. So our aerospace engineering department was founded in 1987. At the time, it was basically the only aerospace engineering program from Seattle to Boulder, down to Los Angeles. We were very proud, to initiate our hands-on program, which quickly got accreditation from ABET. I must acknowledge Dr. Dikta Sotel, who was the first department chair, and he was commissioned by Dean J. Pinson of the College of Engineering in 1985 to design and develop the BSAE program. And 2 years later, in 1987, we opened up our department just with the undergraduate program, the BSAE program. And I happen to be the first tenure line faculty member to be hired, and I'm still here. So I'm very excited about this, to be able to provide this historical perspective, where we've been and where we are right now. In 1989, we had the first transfer students who actually graduated with a BSA degree. Just 2 years later, they basically did the upper division aerospace engineering courses, and they earned their BSA degree. And at the same time, we hired Dr. Hunter, who came from ESL, a local company that was doing aerospace, work, and she was our first full-time lecturer. Dr. Hunter is still with the program. I'm very excited, to announce. In 1991, we received our first accreditation from the Accreditation Board for Engineering and Technology. And we had just exceeded 400 majors. So you could tell that even back then, the demand for the program was very, very high. A year later, in 1992, we started our graduate program with an emphasis on satellite subsystems. So I like to joke about it. Let's see if I can, if the music will show up or not. Okay, good. The music is off. So I like to joke about it. that you cannot teach mechanical stuff, engineering stuff using PowerPoints. So we take pride in having not only an innovative and very broad curriculum. I mean, we cover pretty much every aerospace engineering subject. I invite you to compare our curriculum, our courses, with any other aerospace engineering program you can find, in California or even outside of California. And you'll find that we have basically better coverage of subject areas than any other program. But we also take pride in having a hands-on program, which is supported by state-of-the-art laboratories. So we're constantly working on upgrading our laboratories. And when we hire faculty, we make sure that, they are hands-on people, they know how to develop labs and run labs. So our philosophy is, aerospace engineering program, it's obviously based on hard math and science. And you're going to get a very good and excellent foundation in aerospace engineering, math and science. But at the same time, engineering is about designing and building and testing things. So our philosophy is to integrate analysis and computation, which is how we do a lot of engineering these days: computational fluid dynamics, computational analysis of structures, et cetera, et cetera. Design work, because again, aerospace engineers design airplanes, UAVs, rockets, spacecraft, satellites. So you will learn how to, design aerospace vehicles, and experimentation, supported by a wide-ranging hands-on laboratory experience and projects. So here is a quick look at our curriculum. It's kind of built like a structure. If you look at the bottom, we start with a lot of math, calculus 1, 2, 3, differential equations, linear algebra. We move on with science, primarily physics, 1, 2, 3, and chemistry. And then at the junior level, we have the aerospace engineering core, which is divided in 3 areas: aerodynamics and propulsion, aerospace structures and materials, and aerospace dynamics and controls. We also think electronics is very important, so we have a required course in circuits. And the fun part is at the senior level, where you get to choose a senior design capstone experience, either in aircraft design or in spacecraft design. This experience is integrated with general education requirements. So in the first semester, we talk about global and societal issues in aerospace engineering practice. In the second semester, we talk about technology and civilization and how it relates, to aerospace engineering. The capstone senior design experience is typically one of the most exciting parts of the curriculum, obviously. And I'll give you some examples, what we're doing with that, in recent days. For those of you who are interested in going on into a graduate degree, we also have a very broad curriculum. We make sure that we build depth in each one of the aerospace engineering subjects that you guys learn as undergrads, starting with a course in advanced mathematics, advanced computational fluid dynamics. You have a choice of dynamics, astrodynamics, trajectory optimization courses in the area of dynamics and control. You have a choice in a course in structures, aerospace structures and materials, or vibrations. We have a bunch of courses in aerodynamics, hypersonics. We currently have only one propulsion class, which is aerospace propulsion systems, 267. And then you'll have 12 units 6 units of electives plus the 6 units of your project to specialize in an area that you feel passionate about, that you're very much interested in. You can go into space systems engineering, you can go into aircraft design, you can go into UAVs. These are systems areas, or you can go into one of the discipline areas like aerodynamics, dynamics and control, astrodynamics, propulsion, depending on what your interest is. For any one of you who may have a bachelor's degree in an area other than aerospace engineering, we can still admit you into the MSAE program, but you will have to take a few courses in aerospace core subjects to make sure you have a sufficient background, to do graduate work. So you may have to take a course in aerospace structures, a couple of courses in aerodynamics, flight mechanics, aerospace propulsion, or dynamics and control. And we do get a lot of students, by the way, with bachelor's degree in mathematics and physics, mechanical engineering, electrical engineering. Sometimes we even get people who come with a bachelor's degree from, business or other fields, and they have to, the path is a little bit longer, but a lot of these people have done a great job in the MSAE program. Here's something really, really exciting coming up, fall 2022. The SAGE program, Spartan Accelerated Graduate Education. What is that about? We have an opportunity for qualified students to pursue simultaneously the undergraduate and the graduate degrees. So in 5 years, exactly, you'll be able to get your BSAE and your MSAE degree at the same time, or one of them actually you may complete the requirements for the BSAE degree, a little bit sooner. So how does that work? You apply at the end of your junior year when you have completed 95 units of the BSAE degree. The minimum GPA requirement is 2.5. So we have that, on the low end, but we require B or better in all your junior level courses. Both structure courses, 112, 114, both dynamics courses, 138, 140, controls, 157, 160, 157. There's only one, because the other one is a senior level class. Aerodynamics, 160, 162, and flight mechanics. So if upon completing your junior spring semester, you have at least B's in these classes, you have completed your writing class, which is 100W, then you can apply and you will be admitted into the SAGE program. One of the caveats that we expect approval from the Chancellor's office is what will allow you to complete this program in 5 years is double counting of 6 or 9 units. And we have submitted that application and we expect approval by the Chancellor's office over the summer. But even without that approval, the SAGE program will still go forward. You may have to take slightly higher units, a number of units, in one of the semesters, but you can still actually pursue both programs, at the same time. And if you guys are interested, I can tell you more about this. So that's one exciting opportunity. And now about the labs. This is an example of some of the labs we have. This is the Space Systems Engineering Lab. We're doing a lot of work with NASA Ames Research Center. If you Google up TechEdSat, you'll find out that the CubeSats were actually invented in our department in collaboration with NASA Ames. Dr. Papadopoulos was a pioneer in this area. And so we have established a collaboration with NASA Ames Research Center. Our collaborator is Dr. Mark Murbach, who used to teach also in our department. And We design CubeSats about 10 by 10 by 10 centimeters, where the students basically install simple experiments. The satellites have to go through a very rigorous testing process currently done at NASA Ames. And then they get integrated into a launch vehicle and launched into the space station. Our goal is to develop equipment in our 236 Space Systems Engineering Lab so we can do the certification on campus. And that's very, very exciting. The engineer at Ames who currently does the certification of these microsatellites, Dr. Ali Guarneros Luna, she's a graduate of our program, and she's currently teaching a 110, which is Space Systems Engineering. Here's another example from our Space Systems Engineering Lab. We have the ground station antenna at the roof of the College of Engineering, which allows us to track any satellites in orbit that go over our skies here. Another lab, the Aerodynamics Lab. I ought to take, another more exciting photo of the Aerodynamics Lab, and I go in there all the time, and I still haven't managed to do that. But it's a very nice set of experiments that you guys will get to do. There's 8 experiments in the wind tunnel and 1 in our water tunnel where you do flow visualization and you try to understand, how the flow behaves over streamlined bodies like airplane wings, or the nose of a fighter airplane, let's say, at high angle of attack, and how the flow also behaves when it goes over bluff bodies like a circular cylinder. Hands-on, hands-on, hands-on. Our students love hands-on, and we give it to them. So this is from our senior design experience. Our aircraft design class involves participation in 1 of 2 design competitions. One is the SAE, Society of Automotive Engineers Aero Design West competition, which involves a heavy lift design of an airplane with certain constraints, and also the AIAA Design Build Fly competition, which is much more challenging, and our students find it more interesting. So a lot more teams go into the DBF. We have been doing really well in this competition. There is typically more than 100 universities that participate in the DBF every year. And it's not just from the US, it's also from Europe, from the Middle East, Israel, from South America, Brazil, from Canada, Mexico. And in 2012 and 2016, our teams won first place. This is an amazing distinction. It's a very, very challenging competition. And needless to say, we also got 2 third places in between, and we pretty much place in the top 10 every year. So we have an amazing class taught by an amazing fellow who is actually one of our alumni, Professor Gonzalo Mendoza, currently working at Textron Aviation in Wichita. So he graduated from our program in 1998. So that's regarding the DBF. We also have a very active rocketry club that they like to design and launch rockets. That was a few years ago. The HARP team, high altitude rocket project, and you can see the crater that their rocket created. When it came back, they were trying to set a record and send it over 100,000 feet. They weren't quite successful, but they did learn a great deal from that experience, designing, building, testing the rocket. and our rocketry lab is running very strong these days. Here's some pictures from the TechEdSat that I mentioned earlier. If you Google up, you can find all the missions under a NASA, website. The first one was in 2012, and I believe Ali was involved in that one. You can see the deployment of TechEdSat 1 next to the space station. And the latest one is actually TechEdSat 13, which was launched on 13 January of this year on Virgin Orbit's Launcher 1 vehicle as part of the STP 27 VP mission. Our TechEdSat team earned a commendation from the San Jose City Council. You can see the entire team here. This gentleman on the left, standing on the left photo, is Dr. Mark Murbach from NASA Ames Research Center. This is Dr. Ali Guarneros Luna, who is our alumna and teaches AE110. This is the then mayor of San Jose. This is Dr. Pericles Papadopoulos, in the middle on the second picture. So very, very exciting, and the program has earned our department a lot of distinctions. Talking about alumni, here is the gentleman who is teaching our aircraft design class, earned his BSAE in 1998. He's currently Director of Engineering and Innovation at Textron Aviation, previously Cessna Aircraft. On the right-hand side, we have Dr. Wade Hughes, earned his BSA degree in 1992, went on, got his PhD, and now he's Professor of Aerospace Engineering at West Virginia University. It's kind of interesting because we invited him a couple of years ago, I think it was 2019, to be the external evaluation of our program. We have to do this every 6 years for accreditation purposes. We have obviously lots and lots and lots of distinguished alumni. I just don't have the time to update our alumni page, that often. So this is just a few of the people that I chose to put on the PowerPoint. Anima, who came to us with a computer engineering degree and got her master's in 2010, and her dream is to become an astronaut, currently working at NASA Ames. Jay Westerveld, Mission Operations Manager at Space Systems Loral, got his BS in 2014. Almost set a national record in level 3 rocketry. He sent a rocket to, I believe, 130,000 feet. And unfortunately, one of the instruments malfunctioned, and so the record was not officially given to him. But the experience was absolutely tremendous. This is, what some of our students are saying about their experience in the AE program. We're a small program. You get to work, you get to know a lot of your classmates, if not all of them, actually. You work together with them on a number of projects. You'll spend lots and lots of time in 164. If you guys have an opportunity to see our multi-purpose room with computers and the club rooms and the projects and everything on the first floor of the engineering building. What the first one is Aaron Mazula. He got his BS in 2012, his MS in 2015, and he just got his PhD last year. And now, he continues working at NASA Ames, Research Center. So he says, he got to know professors fairly well, got connected with alumni, and that's how he was able, to get his job at NASA Ames. Tara Samuels, also working at Ames and finishing up her PhD with Embry Riddle. She liked our open-ended real-world problems that we do in our classes, and she just says how these problems help them help her, prepare for the real world, because in the real world, you don't do textbook problems. A lot of the problems are very complex, open-ended. You have to make a lot of assumptions, and that's the kind of thing, we prepare you for. We are very fortunate to have our program in the heart of Silicon Valley, because as you probably know, there are a lot of aerospace companies nearby. This map shows only the big ones: Northrop Grumman, Lockheed Martin, NASA Ames Research Center, of course. And there's also, smaller facilities, by Boeing and Maxar now. But there's also a lot of smaller companies that do innovative things with UAVs, putting payloads into space, and they hire a lot of our graduates. So there's always opportunity for internships and then eventually finding permanent jobs in the Bay Area. I'll take a minute maybe to introduce you guys to our full-time faculty. Here's Dr. Pericles Papadopoulos. His specialization is space transportation and exploration, vehicle design, and computational fluid dynamics. We have Professor Maria Chirichetti, who is also Associate Chair of the department. Her area is structural dynamics and vibration, inverse methods for structural health monitoring of aerospace structures, aeroelastic tailoring, and finite element methods. Our newest addition is Professor Yavo Ezunkpe, and guess what? Professor Ezunkpe is also a graduate from our program. Madison, you have a question?
Yeah, we can't see the people.
Oh yeah, I forgot to share.
Share.
I forgot to share. I'm so sorry about that. Let me see how I can fix that. So share screen, what am I showing? This share. There you go. Okay, sorry about that. So there's Dr. Papadopoulos again, space transportation, CFD, Dr. Chirichetti, our structures lady, structural dynamics and vibration, structural health monitoring, aeroelastic tailoring, finite elements, and Dr. Zunkpe, who joined us last fall. He graduated from our program with his BS degree, and he went on to UC San Diego and got his PhD, and we grabbed him and brought him back and make him a faculty member. So we're very happy to have him in our team. His specialization is thermal fluids, biomedical fluid dynamics, applied computational mathematics, and microgravity science. And we're in the process of hiring new tenure line faculty. We may have another one next fall. It all depends on how the recruitment process will go. And we will have more positions also available next fall. But we are also very proud of our lecturers who bring a lot of interesting experience into the classroom. Here's Brian Andrade, who teaches our aerodynamics class, recent MSA graduate. He currently works at BAE Systems in South San Jose. Dr. Aravamudan, she's teaching programming. She's one of our advisors. Professor Benzio has been teaching our CAD course, A20, for years. Lots of experience from NASA Ames. He's also teaching CAD at the ENSA College. Nick Kramer, he's teaching our UAV course, also from NASA Ames Research Center. I already talked about Dr. Hunter, who's one of the founding members of our department. Her area is primarily dynamics and control, but she has taught spacecraft design. She developed our structures, courses, and laboratories. She's an amazing teacher. Dr. Koshravi, who teaches graduate mathematics. Dr. Kondos, he's a visiting scholar. Dr. Lang in dynamics and control. Dr. Lombards from NASA Ames Research Center, also in dynamics and controls. Dr. Lu, dynamics and controls. Dr. Luna, I already introduced you to Professor Mendoza, Professor Montgomery, another recent graduate from our master's program, and he's teaching aircraft design 271 and 273. Dr. Mark Murbach, the Tech at Sat guy. Emily, another recent graduate who is teaching AE15 and AE100. Dr. Yazdam Bedram Razi, he's teaching 264 this semester. Joseph, who's teaching 112 and 114. Dr. Schultz, CFD. Dr. Sukaras was a visiting scholar some time ago, and Dr. Shan Sui from NASA Ames, also in dynamics and control. And Alisa is one of our recent graduates and also advisor. So that's our amazing faculty. Let's see, I don't know if I have anything else to share in terms of the PowerPoint. All I want to do is just flash quickly my contact information in case you guys don't have it. And I'm open to any questions you might have.
I have a question.
Go ahead, Madison.
I heard in the engineering open house earlier that some professors have research opportunities for students. I was wondering if professors accept undergraduates to work on their research with them in the aerospace department.
Absolutely, yeah. We love students who want to do research, and the sooner you start, the better. So depending on your interests, basically you can approach any of the faculty members and ask them, for ideas about projects. By the time you get to the senior design project, you could have quite an experience, in working on a project with a faculty member. So in the senior design, you hit the ground running, as we say. And we also encourage our students to present papers in conferences. Dr. Papadopoulos is an organizer of the IPPW conference, International Planetary Probe Workshop. And every year we have a bunch of students who present posters in that conference. It's a very prestigious conference that happens with collaboration between NASA and San Jose State and other universities, in Europe. The organization sponsors 5 students from each university, each of 20 universities, I think. So you can apply for one of those, scholarships based on your presentation. But even if you don't get sponsored, we do the best we can, to sponsor more than the 5 students, from our department, and so you get to present. I also organize a conference in Athens, Greece every year, and I'm always encouraging students to co-author papers with their faculty and come and present them. Right now, it's actually a little bit easier because of the transition from COVID. The option to present online, it's still there. And so it costs very little money. You don't have to travel, you can still, present a paper. So the answer is yes. We give lots of opportunities for students to work with faculty on research projects.
Mm-hmm. Thank you. I was amazed at the amount of people that there are from Ames, especially because spacecraft is my primary interest, and I'll definitely have questions for them, that's for sure.
Sounds good. Yeah, it's a spacecraft. Just because of where we are, was the first area that was developed, very strongly in our department. In fact, the undergraduate program was always balanced between aircraft and spacecraft because, when you call a program aerospace engineering, you have to show ABIT, the accreditation agency, that you have all the topics from both areas. But at the graduate level, we started only with spacecraft systems, and we added the aircraft side later on, and I'm glad we did. I mean, that's my area, aircraft, and now there are a lot of applications with UAVs and a lot of interest for sustainable aviation and electric aircraft and this sort of thing. So we have pretty much courses and research opportunities for any interest.
Thank you.
Spencer, I see, has his hand up.
Yeah, thank you. So I wanted to ask a little bit about class size, or just the kind of ratio of student to instructor. I know from reading those little testimonials that you posted there, it sounds like it's a kind of a more compact environment. As opposed to a major like mechanical engineering that has, 35 to 40 plus students in upper divisional classes. Would you say that's primarily true?
Yeah, let me show you something before. See if I can find that. There's a photo which I think illustrates my point, and I want to find that. I just gave a presentation not too long ago. Was that grants 2022? Project grant. Come on. Some project. Yay. It's a good photo, and I wanted you to see it because a picture is worth 1,000 words. Let me see if I can get that somewhere else. It's the same photo. Faculty. Let's see. Oh, I know. It should be. Come on, it's not here. Where is it? It's got to be here. I've shown this photo so many times. There's two of them I want to show you. Yeah, I found it. Yeah. Okay. So so what do I do now? I need to do a share. Okay. You guys see that?
Yes.
Okay. So this is my class when I was teaching aerodynamics. I had 90 students in the class, right? this is not the traditional way of teaching where you go to class, with a pad and start taking notes and someone talks for 75 minutes. If this is the way a class is taught, in my opinion, it's not very effective. And I'm not the only one who says that. There's a ton of research out there that basically says that if you want to learn in class, if you want to teach the students anything, you have to engage them with problem solving and other activities in class. It's no different than learning how to play a musical instrument, right? So if I when I was taking guitar lessons, I paid this gentleman, an arm and a leg for 45-minute lessons, right? If I went there and he spent 45 minutes playing his guitar and I was just listening, I wouldn't be able to learn anything, right? So he had to observe me play the guitar, and he had to correct me the way I was holding the guitar, the way I was playing the notes, et cetera, et cetera. And that's where the learning happens. Same thing in engineering. You have to give students problems to solve, and you have to walk around the room and see what assumptions they make, how they progress, and help them out, right? So this is the active learning approach. If you do the pedagogy right, it doesn't matter whether you have 30 students in a class or 90 students in a class. If you just lecture for 75 minutes twice a week, you can have a class with 15 students. It's not going to be more effective than having a class of 90 students, because PowerPoint and talk is PowerPoint and talk, right? I mean, you don't get to do anything. So some of our classes may be big. Some of our classes, we split them. It's kind of confusing now, because I have excellent teachers, right? And I want to give them one large section of, let's say, XYZ. And the university says, oh, we don't have any classrooms for 90 students. So I have to split them into 2 sections, right? So you get smaller sections. But again, it's the pedagogy that makes the class, effective. Now, moving forward, we may offer one section online and one section in person, if there is interest by students, to take courses online. So there's a lot of factors. But the point I'm trying to make is don't look at class size as the only parameter that determines the quality of teaching. The pedagogy is 10 times more important, and all our AE faculty are very much in tune, with this pedagogy. So any class you take, you're going to go to work in the classroom. You're going to solve problems and collaborate with other students.
Thank you. I appreciate that.
You're welcome. And having said that, our electives, we have about 5 electives now in the senior design. They're all small classes, some of them 10 students, some of them 20, at the most, 25, 30 students, for an elective. The senior design class, aircraft, spacecraft, it's typically about 25, 30 students. Nathaniel.
Yeah, one quick question I want to ask is, like, what kind of hands-on projects are we going to work on? Like, are we like designing aircraft, or like, I just want to know some specifics.
Yeah. So as far as hands-on experiences, pretty much every class has a lab. Some of the labs are shorter, some of them are longer. Some of them are not even officially scheduled. Like the Aerodynamics Lab, we put it on the schedule officially, a couple of years ago. So you see, it's lecture and lab. And as I said, there is 4 experiments in 160 in the first semester and 4 experiments in 162. The structures class, the lab is not officially scheduled. So you basically make arrangements with the student assistant or the faculty member, and you go in small teams, and it's 6 experiments over the 2 semester, period. Dynamics and control, the same thing. There's a bunch of experience. As far as projects go, the most interesting and demanding, projects where you build stuff is in the senior design. So 2 semesters in the senior year in aircraft and 2 semesters, in spacecraft, depending on what you decide to do.
Okay, thank you.
You're welcome. I see a hand from Advik.
Yeah, so my question is that I came across some information and sort of said that about 50% of San Jose State graduates are seeking employment, but they can't find any. So like, what does that mean, sort of? And how many kids do get the job, or is it like guaranteed in aerospace engineering for you to be able to get a job after graduation?
Let me make sure I understand your statistic. Did you say 50% of SCSU graduates, or 50%?
Yeah, sorry, it was 50% of graduates with a engineering degree.
I have not seen that statistic anywhere. Where did you see that?
The first destination survey.
The what destination?
First destination.
Oh, first destination. Yeah. To be honest, I'm not aware of that. First of all, there is it is absolutely true. There is no guarantee. It doesn't matter what degree you have. You may have a PhD from MIT or Stanford. There is absolutely no guarantee, that you'll find a job, right? It depends on your requirements, and it also depends on a number of factors, how the market is doing, and things like that. As far as our aerospace engineering graduates are concerned, I can tell you, I have not heard of anyone who has tried to find a position recently, at least, when I say recently, in the past 5 years, and has not been able to do so. There is a pretty hot market, not only locally, but also if you're willing to go like farther north, at Boeing in Seattle, or, in another state. We had, one question that had come up, for example, is whether foreign nationals who, we have a lot in the master's program, whether they can find an aerospace engineering job, because a lot of them are related to defense work, right? And so you need citizenship and clearance. And I can tell you that even these graduates who did not have citizenship and could not get clearance, they are all placed in very interesting engineering jobs. One of them got to do a CFD in a propulsion company, and the rest, they're working on various positions. Actually, I can show you some of our alumni, just to see that they're. So before I show you the website, the point I'm trying to make is, first of all, there's lots of opportunities locally for aerospace engineering. The demand for aerospace engineers is very strong throughout the US and the world. But more importantly, the way the world is going right now, you cannot expect that you're going to stick with the same job and the same company for more than a few years. If you are lucky, okay? But the way things are working, from what I've been reading and what I've been telling students, it used to be like up until the 80s, you got a job, let's say, as an aerospace engineer at Boeing, and you retired 40 years later, being a manager or a vice president, with the same company. So you stayed with the same company and you climbed the ladder, you made more and more money. In the 90s, that went out the window. companies started luring engineers and stealing them from one company to another because the demand, for brain was high, and so people started hopping from one company to another, but always within the same field, aerospace engineering to aerospace engineering. From what I've been reading, people now will be changing 7 to 8 careers over their lifetime. Not within the same field. When I say careers, you may start as an aerospace engineer and go into business, come back into general engineering, go into marketing, go into higher education, teaching, et cetera, et cetera. And so because of this, we prepare you not only to be excellent aerospace engineers, and I mean that if you look at the curriculum and the laboratories, and the faculty, but we give you the lifelong learning skills which are absolutely necessary for you to thrive in anything you do in life. So we teach you communication skills, team skills, interpersonal skills, design skills, open-ended problem solving skills, hands-on skills, professionalism and ethics, and all of these things. So from what we are being told by industry, these skills are much more important than the actual content that you learn in each class. And the content, of course, is the vehicle for learning these skills. And you're going to learn these skills while learning aerodynamics and aircraft and propulsion, right? But you're learning a whole lot more than that.
Thank you. Thank you so much.
You're welcome. Who else? I see, let's see, is that Safir? Am I reading your name correctly? Sahir.
Yeah, I just had a quick question about what is the internship situation like for undergraduate? Like, is it like compared to graduates? Do they get preference when it comes to internships? And do you know how hard it is for an undergraduate to obtain an internship in the area?
It's not hard. But I'm not gonna say it's a given either, right?
Mm-hmm.
It's a competitive situation.
Yeah.
I've been amazed at how many opportunities are there. I was just talking to my son-in-law, and he introduced me to some guy in some company I didn't even know existed, and all of a sudden I talked to this fellow, and voila, 20 internships for aerospace engineering students, So we got that thing going. So there's a lot of opportunities. You got to keep your eyes open, but they're also competitive. So you have to make sure you maintain, good grades. Brag about your projects, any projects that you have participated, so you have to know how to sell yourself. And we have programs through AAA and the Aerospace Engineering Learning Community to help you polish up, your interviews and your applications, to be more competitive. Spencer, you got another question?
Yeah, just a quick one. I am currently a mechanical engineering major, and kind of the only reason for that is
my condolences.
Yeah, right. The only reason for that so far has been that when I was earlier on in my engineering education, I had talked to some people in mechanical engineering, and they were like, yeah, don't specialize in aerospace because you'll kind of put yourself in a box and limit your opportunities. And it's kind of never sat right with me, but I'm kind of wondering at this point, how easy is it to change majors? If I got accepted into the college for mechanical engineering, do you know at all what the process would be like for me to just change into aerospace?
Yeah, that's a good question. But by the way, I joked when I said, my condolences. I got my bachelor's degree in mechanical engineering. And then I went to Stanford, to do all my graduate work in aerospace engineering. So the two fields, the two engineering fields are closer than any other, But you got to keep in mind, when I got my degree in mechanical engineering, just to see how things are changing very quickly, and they have already changed, very drastically in the last 40 years. When I got my degree in mechanical engineering in Greece, guess what? I had a license to practice as an electrical engineer. When I took the entrance exam in 1975, it was the first year that they split mechanical from electrical. In 1974, it was mechanical/electrical engineering. Now, if you look at the curriculum of mechanical engineers and electrical engineers, there is absolutely nothing in common other than a circuit class, right? And maybe a mechatronics class. The same thing has happened with aerospace engineering, right? Aerospace engineering has exploded in the last 40 years. So there is a lot of specialized knowledge. Yes, the MEs learn fluid mechanics, but we have 3 courses in fluid mechanics. The first one is kind of similar to theirs, but we also have wind tunnel experiments. And then we have aerodynamics 2, and then we have high-speed flow 164, which is aerothermodynamics. So in some ways, the disciplines are different, fluids, controls, structures, but the applications and the specialized knowledge, is very, very different. So what does that mean? If you focus on the skills, when you take an aerodynamics class, focus on learning how to design experiments, how to run the wind tunnel, how to solve open-ended problems. It doesn't really matter that much whether your degree is in aerospace engineering. You can still apply for mechanical engineering jobs, and vice versa. If you're a mechanical engineer, right, you can apply for an aerospace engineering job. With the caveat, though, that if I am an aerospace company, right, and I want someone who knows aerodynamics or aerospace structures, I'm not going to hire a mechanical engineer, right? I'm going to hire, an aerospace engineer, because this person has the specialized knowledge, that I need. So it's a tough situation, I can't tell you do one or the other. Some people decide to get their bachelor's degree in one field and then go to the other field, to get their master's degree. So you have a degree in both areas. So that's a possibility.
I see. Okay, thank you for that. If I did decide to, make that switch, would I just speak to an advisor about that and say, hey, I'd really rather be in this major?
Yeah, if you want to come to aerospace engineering, if you are an ME and you want to come to aerospace, there's no problem. I will admit you. You just have to find out what the rules are, because the college may have some rules in place. If you're admitted into one program, they may not allow you to transfer right away. The Engineering Student Success Center will be the best place, to go for that. I don't want to say something that's incorrect. But if you want to go from a program like aerospace, so a program that may be a higher demand, like I don't know, electrical, or I don't know how impacted mechanical is. The other way around, might be more difficult. It's not impossible, but it might be more difficult.
I see. Okay, thank you.
Any other questions?
I think there's a couple questions in chat.
Oh boy, yeah, I'm not reading the chat. Thank you. So let's see. Chat. What companies should I check with at SASU for internships? So one place to start is always the SASU Placement Center, Career and Placement Center. You can also look at our website. We try to update it, as quickly as we can. So any positions that we get, we post them on the website. So let me share the link. So, for example, here we tell you how to prepare for an internship, and these are opportunities. Some of them may no longer be current, but these are all the companies that in the past they have offered internships, for aerospace engineers. Aerojet Rocketdyne, Air Force Research Lab, Astranis, Blue Origin, Joby Aviation, NASA Ames, et cetera, et cetera. So you can click on any of these links and see what they have, currently. And on our end, every time we get a request, from industry that they're looking for students, to intern, we always put it on the website right away. Let's see. Any other questions I have to leave? Or just say would be the best skill or trade in order to be successful in this career path? Yeah, that's an excellent question from Jaime. So I would say that you have to focus on 21st century skills. What are 21st century skills? Ability to learn on your own. It doesn't matter how good our curriculum is, how state-of-the-art the labs are. When you go out there and you start working, within 2 or 3 years, there'll be new things that you will need to learn, new technologies. So you have to be able to pick up a book, a report, an article, and learn on your own, and go talk to people and get your questions answered. This skill, the lifelong learning skills, are invaluable in today's world. Another one is ability to handle open-ended problems. A lot of the, unfortunately, that's why I take pride in our teaching in our department. A lot of the courses that you take, lower division, upper division, I mean, throughout the US, throughout the world, Greece, India, China, US, they tend to be cookbook. So it's basically plug and chug, here's the equation, put in the numbers, get the answer. Real world problems are not like that. You don't even know what you're looking for. So you have to spend hours and hours defining the problem. What am I looking for? What do I need to calculate, and try to formulate the problem before you start using equations and plugging numbers. So this is a very, very important skill, ability to solve, open-ended problems. Ability to work with others, because you will have to collaborate with a lot of people in a multicultural, environment. So you have to know how to, work with others without rubbing them the wrong way, and, picking up fights, with people and all these things. Communication skills, extremely important. You may be a brilliant engineer, but if you don't know how to write reports, and if you don't know how to make presentations, someone else is going to get your work and present it for themselves and get credit. Okay, so when we say you got to learn how to write and how to present, we do it because we understand, how important communication skills are. So that's what I would say, are some of the most important skills. And also design. And again, design goes hand in hand with open-ended problem solving skills, because design is not cookbook, right? You have to think outside the box, the process is kind of muddy. You have to learn how to iterate over and over. When something doesn't work, you go back and you change something. So all of these things we teach you, in the BSAE program. So we feel very confident that you will get a very good, set of these skills. Let's see. I don't see any more questions in the chat. If you guys have any questions, I see Advik has his hand up.
Yeah, so my question was that what aerospace clubs are on campus? Like, are there any clubs affiliated with the major, or?
Oh yeah, we have clubs galore. The largest one is AIAA, because AIAA is the aerospace engineering professional organization, for our field. So I would say you may have, over 200, 250, members in that club. The other one is Sigma Gamma Tau is by invitation only. So if your GPA is, I forget what it is, you know, whether it's 3.5 or something thereabouts, then you get invited, you know, to join Sigma Gamma Tau, and obviously it's an honor, and we get you involved in service opportunities, you know, like tutoring or other, you know, service opportunities, you know, in the community. Then we have the Rocket Club, which is very popular. You can learn how to launch, how to design, build, and launch rockets, and you can get certified. You can get a level 1, a level 2, or if you can come up with the money, you know, to build a level 3 rocket, you can get a level 3 certification too. Jay Westerveld, by the way, I showed his photo in my slides. He probably paid out of pocket, you know, about $3,000, you know, to put that rocket together, you know, and try to set the national record. And of course, there's opportunities, you know, you guys don't have to get a loan, you know, to build a rocket, you know, there's opportunities to do fundraising and crowdsourcing, you know, and we'll try to help, you know, as best as we can. So Rocket Club, then SEDGE, Students for the Exploration and what does a D stand for, of space? So SEDGE is doing similar things to the Rocket Club. You know, they also design and launch, you know, rockets. And what else? And actually, if you want to find opportunities about these clubs, there's everything you want to know. It's on the website. So let me go here, student clubs, share screen. So you guys can click on any of these links. Advanced Space Exploration, that's another club, ASC, ARAA, Design, Build, Fly. There is also broader clubs which are not limited to aerospace, like Engineering Ambassadors Program, Engineers Without Borders, right? Society of Women Engineers. And here's the Rocket Club. For example, if you click on the Rocket Club, they have all kinds of, you know, cool videos, some of the projects that they've done in the past. And there's also contact information, you know, who the officers are. Send them an email and they'll tell you how to join. Shahir, have a question?
Yeah, so for the like courses, how easy or hard is it for like me to, or I don't know how this works, but if I took like an AP class, so I took AP Calc and AP Physics, and I have like, what is the AP score needed to like, can I like bypass those classes in my first 2 years of college, or how does that work?
Gosh, I don't remember that off the top of my head, but we do accept AP,
Okay.
you know.
Right.
So if you have, I mean, I don't know if you have to have the top score or the second top score, whatever those numbers are, we do accept AP credit. And so you know, you may start with Math 31, for example, and Physics 51. You know, so you don't have to take the first physics or the first calculus course.
All right. Thank you.
Yeah. Are you guys all freshmen? You coming in as freshmen? Okay. So one of the exciting things that we have is the lower division courses, AE20, which is the CAD course, and AE30, which is a programming course. They have projects, and these projects are in collaboration with the senior design project teams. So if your interest is aircraft design, we team you up with one of the aircraft design teams, and they come up with a little programming project for you to do in AE30, or a little CAD assignment that you can do in AE20. These activities are coordinated by Dr. Hunter, who is the director of the AE learning community, and the professors actually, they are on board. So you guys will be meeting, you have a team, let's say in your programming course, AE30, working on a particular program that suits the needs of the spacecraft design students. So you meet with that team of students every couple of weeks to coordinate, what they need done. And so you guys can work on your A30 assignment. And then at the end of the semester, you do a little presentation, and you present your program, to them. So it's a pretty exciting opportunity because that gives you that gives you an opportunity to see what the seniors are doing in aircraft or spacecraft, depending on your interest, and you can talk to them. You can find out, what are some of the things you need to do, to be successful in the program, et cetera, et cetera. Any other questions? Okay, I don't see any more hands. I hope you guys are doing well in these hard times, COVID and all these things. We are about to reopen and hopefully will be fully in person in the fall, or at least 70%, if not more. But at least all the labs will be open, the clubs will be open. And if any one of you has any questions, please send me an email. If you want to meet with me, I'm coming to campus, so we can make an appointment, and I'd love to meet with you in person.
Thanks
Thank
for all
you.
the info today. It was enlightening.
You're very welcome. Anything I can do, let me know.
Yeah, I'll reach out. Thank you.
You guys take care. Enjoy the rest of the weekend.
You
Have a
take
good
care
one.
as well.
Have a good one. You too.
Okay, bye.
Bye.